So here we're going to, in 7b, like in 7a, we're going to work with the left-hand side and use the identities we know to show that it equals the right-hand side. Now, maybe you saw in the part A that one good strategy is, like I always am looking at towards what I want to achieve. And I noticed in part A, the left side was one fraction, and then I wanted the end result to be two separate terms. So a good strategy in part A was to split up the numerator over the same denominator. Well, in part B, kind of similarly, looking at the left versus the right side, the left side has two fractions added together, and eventually I just want a single term. So one good strategy here is let's just combine these two fractions into one, meaning I need to find a common denominator. So that's what I'm going to do. Because right now, by the way, I have no identity I can use. There's no identity 1 minus sine. There's an identity involving sine squared, but not sine theta by itself. So, all right, so let's start there. So I'm going to make this a common denominator, and the common denominator will be 1 minus sine times 1 plus sine, which means for the first fraction, I multiply the denominator and the numerator by 1 plus sine. And the second fraction, I'm multiplying by 1 minus sine. So when I do that, the left fraction, 1 plus sine times 1 is just 1 plus sine, plus 1 minus sine times 1 is 1 minus sine. Okay, so now I've made a single fraction. It's over that common denominator, and lo and behold, the signs go away, and so I'm left with 2 on the top. And then in the denominator, if I FOIL this out, the nice thing is, notice because it's a 1 minus sine, 1 plus sine, the middle terms are going to cancel. So I'm going to be left, when I FOIL this out, I'm going to be left with 1 minus sine squared theta. And whenever you see a squared term, you want to think one of the Pythagorean identities. And the Pythagorean identity involving sine squared is sine squared theta plus cosine squared theta equals 1. So if I have 1 minus sine squared, well, let's see what that equals. It equals cosine squared. So I can replace this as 2 over cosine squared theta. And I know this is the same as 2 times 1 over cosine squared theta. And remember, 1 over cosine is secant. So this is just the same as 2 secant squared theta. And just one reminder what this actually means. This superscript means you're taking the secant of an angle, that ratio, and squaring it. This is just the shorthand of writing that. We write it like that. So that is 7b. Again, so I always pay attention to the left side, what I am starting with, and the right side, what I need to end with, and then that helps inform my strategy. So having 2 fractions, knowing I had to get to a single term, that helped me realize, okay, let's try to make a common denominator. All right, so now let's look at 10. Oh, yeah, these get hard. So lots of strategies, different strategies, which is something I like about these problems is there's different ways to approach it. Some are going to end up being more elegant than others. Like some strategies for identities are writing everything in terms of sine and cosine, using Pythagorean identities, as we just saw, making common denominators, or splitting up a fraction by putting it over the same denominator. All right, so here I'm working with the left side to make it look like the right side. So I notice I've got this tan squared and, of course, this cotangent squared. And there are identities involving both of them. So let's remember what those are. I've got the 1 plus tangent squared theta equals secant squared theta. The one involving cotangent is 1 plus cotangent squared theta equals cosecant squared theta. So maybe that'll be helpful. So looking at this, I actually can change the 2 into 1 plus 1. So I could rewrite this instead of using this angle here. I'm just going to use theta because it's easier. So I'm going to say tangent squared theta plus 1 plus cotangent squared theta plus 1. And hopefully you see that that is the exact same thing, because 2 is just 1 plus 1. And lo and behold, 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. Okay, good. But then you're like, wait, this is weird, because I've got secant squared plus cosecant squared, and I need it to equal multiplication, which seems odd that it will do that, but it actually will. So, but we're not done because we haven't proven that yet. All right, so now there's nothing I can do if I just am looking. I don't want to go back using the Pythagorean identity because that will just get me back to where I started. So maybe now's a good opportunity to change things in terms of sine and cosine. Again, the thing I love about this, but it's also very frustrating, is you kind of don't know what to do necessarily. You just have to try something. And so I didn't know what to do. I don't want to go backwards, so I'm just going to try something using a different identity. Okay, I've got 1 over cosine squared plus 1 over sine squared. All right, let's maybe make a common denominator, which is cosine squared sine squared. All right, that means I needed to multiply the first fraction by sine squared over sine squared, so it would be sine squared theta. And the second one I needed to multiply by cosine squared over cosine squared, so plus cosine squared theta. But guess what? Sine squared plus cosine squared theta, that's an identity, and it actually equals 1. So I've got 1 over cosine squared theta times sine squared theta. But this is just the same thing as 1 over cosine squared theta times 1 over sine squared theta, which is secant squared theta times cosecant squared theta. Oops, forgot the little c. Yeah, I mean, that one's a tough one. And again, there's many different ways to approach this. That was probably the most elegant and efficient way. But sometimes, again, people change that to sine over cosine and go from there. This just takes a little bit longer. All right, so that was 10. And let's now look at 11. So 11, again, working with the left side to make it look like the right side. And on the right side, I only have sine. So that's kind of tempting me to rewrite the left side in terms of sine and cosine. So I've got 1 over cosine t, because that's what secant t is, minus sine t over cosine t, because that's what tangent is, times secant is 1 over cosine t. All right, well, the nice thing here is that inside here, they already have a common denominator, so let's just write it over the common denominator. And then I've got times 1 over cosine t. Well, cosine t times cosine t is cosine t squared, or cosine squared t. And then, again, paying attention to the right side only involves sine. Well, cosine squared t, remember the identity there. It's sine squared plus cosine squared is 1. So if I have cosine squared, I can rewrite that as 1 minus sine squared. And here is where usually people get a little bit stuck, because you want to recognize the fact that 1 minus sine squared of t is actually a difference of squares. So I can factor that denominator. I can factor it to 1 plus sine t times 1 minus sine t. And the nice thing about that is the 1 minus sine t's cancel. And then I'm left with exactly what I want, which is the 1 over 1 plus sine t. So no matter which way you do 11, at some point you're going to end up with that difference of squares, and you've got to just recognize the fact that it is a difference of squares and you can factor it as such.